Welcome student, welcome to the next session. In this session we are going to learn the last part of your unit 1 under your topic of cryptography. Okay, so that topic is nothing but pseudo-random bit generator. Okay, now we will go quickly through the basic of what is pseudo-random generation or why do we require it. As I have already told you all, okay, when you are doing the last example of OTP, that is one-time paired, okay, for this OTP require something which is called as some random number generation. Okay, so why do we require this pseudo-random bit generator is nothing but it is used as a key. Okay, pseudo-random bit generator can be used as a key for your OTP algorithm or for your DES algorithm that you are going to learn in your second unit. Okay, and AES algorithm. AES algorithm is also present. DES is nothing but data encryption standard, and AES is the advanced version of data encryption standard that is called as advanced encryption standard. So whenever we require key, now as a key we will require some random numbers. Okay, those numbers have to be generated. Now over here when we talk, as an example we use very small encryption and decryption like hello or plain text as hello or plain text as meet me after the house party or whatever it is. But actually when we are sending the data, we will be sending a lot of data. Okay, so that time we will require very often we will require key values, okay, random key values. So for that we use something which is called as pseudo-random bit generator. Okay, now in C there is a function called as RAND. Okay, this function you might have already seen this function. So RAND, so which can generate a number in between 0 to 65535. So you just have to give a value over here in between which values you need to create the random numbers. Okay, then those many random numbers will be created using this function in the C called as RAND. Okay, now going to the pseudo-random bit generator, okay, we can generate pseudo-random numbers, okay, random numbers using two methods. One is linear congruential generator, okay, and the second one is blum-blum-shub, or also called as quadratic residue generator. Okay, so in most of your question paper, okay, questions have been asked on your linear congruential as well as your blum-blum-shub. Okay, now general method, what do we exactly do in random number generation? Okay, the method remains the same. Okay, the method is not going to change, the method will remain the same, only the formula to generate the random number is going to change. Okay, that is nothing but a deterministic process. Whatever process that we are using to, the formula that we are using to generate the random number is going to change. Okay, the structure will remain the same. So what happens in the structure is nothing but, as you see over here, a seed value is being provided initially to the deterministic process. Okay, now why do we require this seed value? Why do we require this seed value? This seed value is nothing but, initially if I want to generate any random number, without any input can we generate a number? Without any input given to it, can we generate a number? No, without the input we cannot generate a number. So we require an initial seed value. That value, initial value that we give to the system, nothing but called as seed value. So initially the seed value is given to this deterministic process. So this process is nothing but formula which we are going to use to generate a random number. Okay, now what will happen initially when the seed value is given to deterministic process, it will give me an output. So seed value will be a short string, okay, and your output value that we are getting will be a long string. So for short value, initially for a short value, okay, we are getting a long string. Okay, so for example, if I give you input as 2, I will get the input as 133 or 144. So for this seed value of 2, I am initially getting the input. Now for the second random number that we want, what would we do now? Okay, the output of the first method. Now seed value is only for the first step. Only for step number 1 we will use seed value to generate the first value. Now to generate the second value, we have to use the first value, okay, that will be called as a feedback value. The first value as an input to our deterministic process. Okay, very simple diagram to understand how to generate a pseudo-random number. Okay, do not worry about this deterministic process. We will see what is deterministic process. Okay, with respect to linear congruential and with respect to blum-blum-shub, what is this deterministic process we will see later. But as of now, initial value or seed value is given to the system. Okay, that is nothing but a short value or a short string. Okay, it goes to the deterministic process. Okay, and for the second step, the output of the same first process is taken as a feedback and given to the deterministic process will give me the long string. Okay, so just keep this thing in mind. So this is nothing but your pseudo-random bit generation diagram. Okay, it is in general, it's a figure for pseudorandom bit generation. So let us jump to the first step of pseudorandom bit generator, that is nothing but linear congruential generator. Okay, what happens in linear congruential generator? How does it work? Okay, what are the advantages and what are the disadvantages? We will see in this session. Okay, in the next session we will do the blum shub. Okay, that is the residue generator. Okay, so you have already taken a look at the previous diagram. Okay, what was there in the previous diagram? I was taking x0 value as the, I was taking initially a seed value. Okay, in this example I am taking the seed value as x0. I am naming that seed value as x0, the initial value that we give to the system. Okay, now this is nothing but your deterministic process, what we were discussing. So this is the formula using which I am going to calculate my different random numbers. Okay, so in this case, what's the formula? Just keep the formula in mind. Xi plus 1 equals AXI plus B mod of n. Okay, xi plus 1. So to calculate the, for example, if the value of I is 1, okay, if the value of I is 1 over here, so what it will become? It will become 1 plus 1, 2. So to calculate the value of x2, what I need is nothing but, I will need the value of x1, because I is nothing but 1 we have taken, value of A, value of B and value of n. So just keep this formula in mind. Xi plus 1 equals nothing but AXI plus B mod of n. Okay, and the diagram remains the same. So this is a seed value, this is a short input that is given by us. So we get here a long stream output. Same, the output of the first process is given as an input to the second. Output of the second will be given as an input to the third. In case of this feedback. Okay, so just keep this formula in mind. So let us jump to a problem. So in a problem, value of x0 will be given to you, value of A will be given to you, value of B will be given to you, value of n will be given to you. So everything will be provided to you in the problem. Only they will mention that using linear congruential solve this particular problem where value of x0 is this, A, B and n. So you need to just solve the series, you just need to find a series of random numbers that can be generated, where to stop in this process. So you will learn with this example. So let us take the first example. In your first example, okay, I am taking, so in my first example, okay, the x0 value that is given to me is nothing but 7. Okay, value of A that is given to me is nothing but 4. Okay, value of B is taken as 5 and value of n is given as 17. So using linear congruential generator, I need to generate the random numbers. Okay, so what I do now, very simple, very simple, directly write down the formula. So in step number 1, what I will do, so step number 1, so how many steps will be present over here? As many number of repetitions, those many steps will be present. Okay, so now write down the formula straightforward. It is nothing but xi plus 1 equals, okay, xi plus 1 equals nothing but AXI plus B, okay, AXI plus B mod of n. Okay, now initially for what values we need to find? Okay, we will, for I tending from 0. Okay, we will start from I tending from 0. So always we have to start from I tending from 0. Okay, so now I value is equal to 0. So replace this x 0 plus 1 is A x naught, okay, plus B, correct, because in place of I have taken value as 0. Okay, mod of n. Okay, now replace this value. We know what is x is 0. 0 plus 1 is nothing but 1. So what is the value of x1? We don't know. We need to calculate the value of x1. To calculate the value of x1, what do we require? A. What is A? 4 as per given to us. What is the value of x0 is given to us? x0 value is already given to us as 7. So I will take that value x0 as 7 plus B. B value is already given to us as 5. Okay. 5 mod of n. N value is already given to us as 17. So I am writing mod of 17. Okay. Very simple calculation. What is 4 into 7? 28. 28 plus 5 is how much? 28 plus 5 is 33 mod 17. What is 33 mod 17? Okay, so when I saw this, I get it as 33 mod 17. Okay, very simple. 33 mod of 17 is nothing but I am getting the value as 16. So value of x1, I have got it as 16. Okay, just mark this value like this because we will require this value later. Okay, similarly, now I equal to 0 is done. Okay, now we have to do for I equals 1. Okay, now the question here is, when do I need to stop? Okay, I will do it for I 0, 1, 2, 3, 4, 5, 6. Okay, we need to stop the process when we get this number again. Okay, the moment I encounter this 16 number again, okay, I will have to stop the process. Okay, why do I need to stop the process? Because Again, after 16, the number you will get will be the repeated sequence that we will be doing now. Okay, forward. Okay, let us see when it comes to the problem. So now I equals 1. Okay, for I equals 1, what I'm going to do now, just substitute in the formula. Now I'm not going to write down the formula. So I equals 1. So x1 plus 1 equals a x1 plus b mod of n. Okay, plus b mod of n. Just substitute x1 plus 1 is 2. I need to calculate what is x2. A value we know, value of a is 4. Value of x1 that we have calculated over here, that we have just now calculated over here is nothing but 16. 4 into 16 plus value of b is 5, and this is nothing but mod of 17, and value is already given to us. What is 4 into 16? 64 plus 5. 64 plus 5 is nothing but 69. So x2 is nothing but, my x2 value is nothing but 69 mod of 17. What is 69 mod of 17? When I solve this 69 mod of 17, I am getting answer as 1. So the value of x2 I have got it as 1. Okay, the value of x2 I have got it as 1. Okay, now what is the third sequence that we need to calculate? Okay, for I equals 3. Okay, for I equals 3. So I want you all to find out what is the value of for I equals 3. Okay, and let me know what is the answer. So as per the equation, the value of x3 as told by you all, the value of x3 will be nothing but 9 mod of 17. Okay, which is equal to 9. Okay. Similarly, now I want you all to find out the value of I equals 4 and for I equals 5. Okay. So I repeat it again, the value of I equals 2, that is nothing but x3, the value of x3 we are getting as 9. So you need to calculate what is the value of x4 and x5, for which your I value will be 3 and 4. Okay, so the value of x4, when I equals 3, the value we are getting x4 as 7. Okay, now can you see 7 anywhere we have used previously? Any value of x was having 7. Okay, the value, if we see properly, the value of x0 that was given to us, okay, the x0 value that was provided to us was nothing but 7. Okay, but initially we had not considered that 7, no, starting. So we had started with directly the step number 1, where what is your x1. Okay, so we had not considered x0. Okay, so here you can consider this x4 because our x0 value was 7, which we have not considered previously. If we have considered it previously, okay, then we cannot consider x4 value because it will be a repeating value. 7 is repeating again. Okay, now to verify whether after 7 what number we have generated, after 7 we have generated this number as 16. To verify whether again the same series is getting repeated again, what we will do is we will just calculate for value I equals 4. Okay, that is nothing but x5. So again it will be similar. For x5 what it will be a value is nothing but 4. Okay, into x3, into x4. x4 is nothing but this value which we have to take. x4 into 7 plus 5 mod of, definitely the answer will be similar, mod of 17. So 4 into 7 mod of 5 is nothing but we are getting the value of x5 as again back to 16. Okay, this is nothing but exactly what we have done over here. 4 into 7, okay, plus 5 mod of 17. So 4 into 7 plus 5 mod of 17 is nothing but, your value here is nothing but 16. So can you see now after 7 which value you are getting? 16. If you do further after 16, your value, the next value of x2 will be 1. So after 16 we will be getting 1. After that we will be getting 9. Okay, that is value of x3. After that again we will be getting the value 7. So now you are getting, where do you need to stop? The moment you get the repeat number again, that time from that step you have to stop. Okay, so therefore we can say that the set of random numbers that we have generated, okay, the set of random numbers that we have generated is nothing but from x1. Okay, x1 is 16. Okay, what is x2? x2 is 1. Okay, what is x3? x3 is 9. What is x4? x4 is 7. Okay, now see, after this we cannot take because after this number is 16. Okay, 16 is again repeating. Okay, so this is basically your linear congruential generator. Okay, so in your linear congruential generator, what happens is you are generating a series of number by giving x0 as an input. Okay, and the formula here is nothing but axi plus b mod of n will calculate what is axi plus 1. So in this case, the sequence which is generated using linear congruency is 16, 1, 9 and 7. So which is going to repeat. Now, what conclusions we can make from here is nothing but this is a very poor random number generator. First of all, why it is poor random number generator? Because very less numbers are generated. Okay, only 4 random numbers are generated over here. So that's why it is called as a very poor random number generator. Second thing which I can say that the numbers which are generated over here are a very small number. Now for example, we require bigger numbers. Okay, for example, if we want bigger numbers, okay, to be the key of any algorithm, because these random numbers will be used as a key to many algorithms, as I have explained to you previously. So we require a bigger number. For that, we will use an algorithm which is called as Blum-Blum-Sharp. Okay, it is a complex version of your linear congruential generator, more robust, okay, and more stronger compared to your linear congruential generator. Okay, so I want you all to just go through this linear congruential generator once again. Okay, in the next session we will be doing with our next generator. Okay, that is pseudo-random bit generator. That is nothing but Blum-Blum-Sharp. That's all for this session. Thank you.